Hello students, it's Nazia Begum here, your physics lecturer, welcoming you all in today's lecture. So today we are going to start a new chapter, that is chapter 12, thermal properties of matter. So what is matter? You all know, we have already discussed that matter is something, okay, from which all the objects are made up of. Matters exist in three states: solid, liquid and gases. Okay, and about their intermolecular forces, shape, size, etc. we have discussed in previous chapter. So now let's start the chapter. So here is the first topic, that is heat and temperature. Here we are going to study about the thermal properties of matter. So heat plays very important role. So what is heat? Heat is a form of energy, okay, and this energy flows from one point to another by virtue of temperature difference. Okay, what is temperature? Temperature is nothing but only the effect of heat. Okay, temperature is an effect of heat. If we say that temperature is more, that means heat at that particular place is more. And when we say temperature is less, that means heat at that particular place is less. If we supply heat to any object, if the amount of heat increases, so the temperature also increases, and if the amount of heat decreases, the temperature also decreases. So basically heat is a cause, okay, heat is energy which is the cause, and because of this cause there is one effect which we call as temperature. So temperature is nothing but the measurement of heat. Okay, the sum of the kinetic and the potential energy of all the atom molecule of a body is called its internal energy. A part of this internal energy transferred to another body is called heat energy. Okay, so heat energy is the internal energy of a body in transit. In transit means it transfer from one place to another place according to the uh, temperature difference. Heat energy is not possessed by the body. Okay, it is not possessed by the body. We have to supply it. SI unit of heat is joule, and common unit or CGS unit is calorie. 1 calorie equals to 4.18 joule, or we can simply write 4.2 joule. Then here is definition of calorie. 1 calorie is defined as the amount of heat required to raise the temperature of 1 gram of water from 14.5 degrees Celsius to 15.5 degrees Celsius, that is through 1 degree. Okay, so if we are having 1 gram of water, to raise the temperature of the water by 1 degree, that is from 14.5 degree to 15.5 degree, so difference here is 1 degree. Okay, so to raise the temperature of 1 gram of water by 1 degree Celsius, how much amount of heat we need, that is called 1 calorie. Okay, then temperature is the degree of hotness or coldness of a body. So temperature is only the degree of hotness and coldness. It is only used to measure the amount of heat and nothing else. Okay, here is one more definition of temperature. Temperature of a body may be defined as the thermal state of the body which determines the direction of flow of heat from one body to another when they are placed in contact. It is a macroscopic concept. So we have already discussed that heat is energy which flows from in according to the temperature difference between two bodies. Okay, so wherever the temperature is high, the heat flows from high temperature to the low temperature. So from here we can see that we can also determine the flow of heat. Okay, temperature actually tells us about the flow of heat. Okay, where the temperature is high, from there the heat will flow to the low temperature. So it tells us about the direction of flow of heat. Then next is measurement of temperature. Temperature of a body is measured with the help of a device called thermometer. Okay, it makes use of some measurable property which is also called thermometric property of a system that varies with the temperature. So in thermometer we use some property of matter which actually varies with the temperature. Okay, with increase in temperature some properties are there like length, volume, pressure, etc. They also increases. So on the basis of this we use different materials on in thermometer. To measure the temperature we need to construct a temperature scale, okay, with two fixed reference points. One will be initial point, second will be end point. Okay, the two convenient fixed reference points are the freezing point and boiling point of water at standard atmospheric pressure. So in any thermometer, how we decide the two points? The two convenient fixed reference points are the freezing point and boiling point of water at standard atmospheric pressure ATP. Okay, these are called lower point and upper point. The freezing point is lower point and the boiling point is upper point of the temperature scale. Okay, then according to their range and lower and upper point, temperature scales are of so many type. So here we are going to discuss about some scale. So first one is Celsius scale. Okay, in Celsius scale when we measure the heat, it is also called centigrade scale na. So when we measure heat by this, the freezing point of water in terms of Celsius or centigrade is 0 degree. Okay, so the lowest point of this scale is 0 degree centigrade and the boiling point is 100 degree. Okay, according to Celsius scale the starting point is 0 degree and the end point is 100 degree. So this scale's range is 100. Okay, range is what? Maximum number minus minimum. Okay, so upper limit minus lower limit is called range. So range of this scale is 100. That means it measure temperature difference till 100 degree centigrade. Okay, then next scale is Fahrenheit scale. This scale was designed by Fahrenheit and it labels freezing point of water as 32 degree Fahrenheit. Okay, so in case of Celsius scale we were having freezing point as 0 degree Celsius, but here the freezing point is what? 32 degree Fahrenheit. Okay, so here on the starting point, on the lower point, how much difference is there? 32 degrees difference is there. Okay, in terms of Celsius the freezing point is 0 degree, but in terms of Fahrenheit the freezing point is 32 degree. Okay, and the boiling point of temperature boiling point of water here is given as 212 degree Fahrenheit. Okay, so if we subtract lower limit from upper limit, that is 32 degree from 212, if we subtract we will get 180. Okay, we will get a division of 180. So that means here what is the range of scale? The range of scale is 180. Okay, 180 degree change in temperature we can measure from Fahrenheit scale. Okay, so if we have to convert temperature from degree Celsius to degree Fahrenheit, so we can use this formula. Okay, this formula is given here. C minus 0, that is initial lower point we can say, C minus 0 upon range of C, that is 100, and F minus 32 is the lower point for Fahrenheit, so F minus 32 upon its range 180. Okay, this is the formula. Or if we divide it, okay, by 20, so 25 is a 100 and 29 is a 180, so we get C upon 5 equals to F minus 32 upon 9. So this formula we have to convert centigrade into Fahrenheit or Fahrenheit into centigrade. So remember this formula. Okay, then next scale is absolute temperature scale. Okay, this scale was designed by Lord Kelvin and also called Kelvin scale. Actually, different thermometers calibrated at the freezing point and boiling point of water agree 0 degree centigrade and 100 degree centigrade, but they may not agree exactly at intermediate temperatures. Okay, it means that at any other temperature they may indicate slightly different readings. Okay, so let me first tell you what is the phenomena of absolute scale, then we will continue with this scale. Okay, so here in front of you, you can see one figure in which you can see one graph is there. Okay, in this graph, on the x-axis, temperature T degree Celsius is written here. Okay, so on the x-axis, what we are representing? We are representing the temperature in degree Celsius. At positive side, plus 100, plus 200, plus 300, etc. On the negative side, minus 100, minus 200, etc. Okay, and in y-axis we are representing pressure. Okay, so with this graph, right now you simply ignore this side. Okay, we will talk about this side only right now. So here you can see that when the temperature is 0 degree, here the value of temperature is 0 degree, then also the matter is having some amount of pressure. Okay, it's not zero, and as we increase the temperature, it is also increasing, and hence we are getting a straight line. Okay, so here we have seen that with increase in T, P also increases. So here with increase in temperature, the pressure is also increasing. It means that if we decrease the temperature, the pressure should also decrease. Okay, so here we have decreased the temperature below 0 degree. So we have noticed that pressure is also decreasing. Okay, and at minus 100 degrees Celsius, the pressure doesn't become 0. Okay, pressure is not becoming 0 here. So what we have done, we simply extrapolate the ray at the back side. Okay, to find out that where we will get the value of pressure as 0. So here at one point we can see at minus 273.15 degrees Celsius, we are having pressure equals to 0. I hope you all are understanding here that with increase in temperature, the pressure is also increasing. So we simply have assumed that if with increase in temperature, pressure is increasing, so with decrease in temperature, pressure should decrease also. Okay, and that's why we have simply extrapolate the ray at the back side. So this ray is meeting 0 of y-axis at a particular temperature, which is minus 273.15. So we have assumed that at this temperature the pressure becomes 0. Okay, the pressure of the gas becomes 0. So this temperature we called as absolute temperature, where the pressure of a gas becomes 0. But ideally it is possible. In practical life it is not possible, because in practical life we cannot obtain a situation where the pressure of a gas becomes 0. It is not possible practically. It is simply a hypothetical situation. Okay, here this part of right hand side one is practically possible, that if we are increasing the temperature, the pressure is also increasing. This part is possible. But this part, that when we are decreasing the temperature, the pressure should also decrease, this part is ideal. Here we have simply assumed that this will happen. So we extrapolate the ray backside, extrapolate the line backside, and it is meeting at this point. Okay, so here we have assumed that at minus 273.15 degrees Celsius the pressure of the gas becomes 0, and that's why we have choose this temperature to be absolute 0. Okay, so the 0 of Kelvin scale, 0 of Kelvin scale is actually in degree minus 273.15 degrees Celsius. Okay, so the lowest point of Kelvin scale is called absolute 0, which is actually minus 273.15 degrees Celsius, and the highest point of Kelvin scale is 100 Kelvin. Okay, so according to this absolute scale, that 100 Kelvin will be minus 173.15 degrees Celsius. I hope you all have understood the phenomena, this phenomena, how we have find out the absolute value. Okay, so here you can see that any other temperature they are indicate slightly different reading. The disparities between different thermometers are large when the temperature to be measured is far from the fixed reference point. Okay, like in degree Celsius the lower point is 0 degree, but in Fahrenheit the lower point is 32 degree. Okay, 32 degree Fahrenheit. And as we go up, as we increase the temperature, then what happen, the water starts behaving in some random manner, some different manner. Okay, so in all the temperature which are related to each other, the water doesn't react or behave similarly. So that's why we need one scale where we will get absolute or correct value of temperature, and that's why we have invented that absolute scale or Kelvin scale. Okay, the temperature minus 273.13 degrees Celsius is called the absolute temperature. Sorry, 15 it should be, not 13, 15 degree is called the absolute temperature, and the temperature scale with its 0 at its temperature is called Kelvin temperature scale or absolute scale. The unit size on Kelvin scale is same as on the Celsius scale. Okay, so if we have to convert Kelvin into Celsius or Celsius into Kelvin, only one value is very important, that is 273.15. If we have to convert Celsius into Kelvin, you simply add 273.15. If we have to convert Kelvin into Celsius, we simply subtract 273.15. Okay, because here you can see Tc, that is temperature in Celsius, is 0 degree. So that time temperature in Kelvin is 273.15 degree, because there is difference of 273.15 between centigrade and Kelvin. Okay, so boiling point of water here will be 100 plus 273, that is 373 Kelvin. Okay, then we will have one general equation, a general formula to convert Fahrenheit, centigrade and Kelvin into different each other's form. Okay, so here you can see on numerator Tc minus upper point upon range, then here for Fahrenheit Tf minus upper point upon range, and for Kelvin Tk minus upper point upon range. So this is one common formula. With the help of this formula we can convert temperature from one scale to another scale. Okay, this is it for today's lecture. Tomorrow we will study about thermal expansion. Okay, and in this chapter many interesting things we are going to study, so be ready for that. See you in next lecture. Till then, goodbye, take care, do some productive work, and the most important thing, be healthy, be safe.